All right, in 30A, we are going to attempt to figure out if this function is homogeneous. So let's start with the definition. A function is homogeneous if, for anything in its domain, x, and for any scalar, c, in our case, scalars are numbers. Later on, scalars will be other things, but let's not do everything in Chapter 1. F of c times x is c times f of x. Okay. Now, if this statement is true for every scalar c and for everything in the domain of f, then everything x in the domain of f, then we have homogeneity. Okay, so the characters in this story are x, something from the domain, the thing that f turns it into, f of x, c times x, the thing that f turns c times x into, and then c times f of x, the odd guy out. And the idea is to make sure that this blue thing and this red thing are the same for arbitrary c and x. Now, that is if we want to show that something is homogeneous. So if we want to show that something is not homogeneous, then it's sufficient to show that this equation right here is false for a particular x in the domain of f and scalar c. For showing homogeneity, though, to show that f is homogeneous, it is, necessary. That was a typo. To show the equality holds, is true for arbitrary x and c. Really, I should say for arbitrary x in the domain of f and for arbitrary scalar c. But hey, I've only got so much time, and you've only got so much patience. Let's get this thing going. All right, for the function f that assigns to x the number 3x, I'm going to look at the particular value of x5 and the particular c2. Okay. Particular value of c2 and particular value of x5. And I'm going to compare f of c times x and c times f of x. So that's comparing these two things. Now, f assigns to 2 times 5, 3 times 2 times 5, which means that f of 2 times 5 is 30. And 2 times f of 5 is 2 times 3 times 5, and that also is 30. So let's get the picture drawn for this. The characters are, first off, the thing playing the role of x in black is 5. So I'll draw a black arrow out to 5. And the next character is c times x, and that is 2 times x, which means I have drawn a stupid picture. I needed to go all the way out to 10. Oops. How can I do this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then, yeah, we increase going that way. I'll try to be more careful in the future. Let's see. Now, this is going to be 5, 6, 7, 8, 9, 10. That's a 10 right there. And in blue, I want to put an arrow that represents c times x. Yeah, so c times x, meaning this is c times x, or 2 times 5. And in black, I want to say that this was x. And then those are the only two things to draw in the domain. In the codomain, get out of your hand, I have 3 things to draw: f of x, f of c of x, and c times f of x. Let's do that. This time, oh, wrong color. Black for the axis. I need to go all the way out to 30. So I'll make it nice and long. Start at 0. Let's see. 10, 20, 30. Okay. And what do I need to draw? I need to draw f of x. F takes x, which is 5, to 10. No, to 15 rather, right? Let's see, so here we'll have 15, and that is 3 times 5. Good. So f of x, in black, is 3 times 5. An arrow going out to 15 will represent that. And f of cx, now cx is 2 times 5, that's 10. Right? Cx is 2 times 5, that's 10. And so in blue, I want to draw what f turns cx into. F turns cx into 30, so in blue, I draw an arrow going all the way out. I want to draw it down there so you can see it, to 30. And that is f of cx. All right, now, the last thing to do is to take f of x right there and multiply it by c. Okay. And c times f of x, let's see, f of x was 15, and we need to multiply that by c, which is 2. So 15 times 2 gives us 30, and that gives us yet another arrow in red. It goes all the way out to 30, and indeed, the arrow c times f of x, c times 15, or 2 times 15, is exactly the same thing as f of c times x in this case, for these particular values. Now, all that I've done so far is thought it would be nice to show that this function was not homogeneous by using particular values, and I failed to do so. With these particular values, the equality actually worked out. So let me see if I can show that for arbitrary c and x, this equality holds, in which case I will have shown homogeneity for this function. Okay, now I'll say similarly, for arbitrary numbers, x and c, f of c times x is 3 times cx, and c times f of x is c times 3 of x. Okay, and I can use my is equivalent to symbol twice here to fill in the sentence and say f of cx is 3cx, and f times c evaluated at x is, no, it's not a parentheses, that's c, just a really ugly one, sorry about that. C times f of x, and now look, because multiplication is commutative, I can change the order of things that I multiply, 3cx. Okay, then I have shown that these two things are equal, these two expressions are equal for arbitrary numbers c and x, so I have showed additivity. So, f is, sorry, homogeneity, homogeneous. I'm tempted to put a big smiley face, but I'll have to do that off the record.